What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 12, Section 5, Conic Sections in Polar Coordinates. Let's do it. Question number 1, explain how eccentricity determines which conic section is given. So we basically got three different categories, right? First, if eccentricity is less than 1, this would give us an ellipse. Option 2, if it's equal to 1, this means it's a parabola. And option 3, if eccentricity is greater than 1, then it's a hyperbola. So that is how you can tell. Boom, done. If a conic section is written as a polar equation and the denominator involves sine theta, what conclusion can be drawn about the directrix? If we draw this out in polar coordinates, right, we know that this is the polar axis. And that means that our directrix will be parallel to this, meaning it's a directrix coming across like this, and then the parabola would, of course, go like that. So anyways, that's how you do it. Done. What do we know about the focus/foci of a conic section if it is written as a polar equation? So what's going to happen is that one of the foci or the focus is going to be right here at the origin. So depending on whatever it is, that's going to be the case once we do the conversion. So that's how you do it. Done. So starting with this baseline formula, the first thing we have to do is figure out what is E, and that's going to help us to figure out what is the conic section. So the beginning part is recognizing, hey, this value is a 1 here, so I need to convert that 4 to a 1 by multiplying by 1/4. But if I multiply the denominator by 1/4, I have to multiply the numerator by 1/4 as well, because 1/4 over 1/4 is 1, and that's all good. So now we're going to get 1/4 times 3, which is 3/4 over 1/4 times 4, which is 1, minus 1/4 times 4, which is 1 sine of theta. So now I know that my E value is right here, whatever's multiplying the sine function. So E is equal to 1. And when we have an eccentricity of 1, it means we have a parabola. And if E equals 1, recognizing that the numerator is E times P, that means 1 times P is equal to this numerator of 3/4, meaning divide both sides by 1, the P value is 3/4. And so since P equals 3/4, we can say that the directrix, which is going to be like this, right? It's going to be parallel to the polar axis. It's going to be 3/4 below the origin. So that's how you do it. Done. So for this one, what we're going to do is we're going to start by getting it into this nice format where we've got a 1 right here. Now, we already have that 1, so we're kind of in a good spot here, because I now know that if we got a 2 here, we know that the eccentricity, or E, is equal to 2. Moreover, since I know that this numerator up here, 5, is E times P, right? We can say 5 equals E times P. Since we know that E is 2, we can sub that in. We got 5 equal to 2P, divide by 2, divide by 2. And now we got our P value of 5/2. Once again, because we have sine in the denominator, we know that the directrix is going to be parallel to the polar axis. So, but again, because it's that positive 5/2, or that plus sign here, right? We know that the directrix is going to be up here, and here we got a distance of 5/2. Last but not least, because we know that the eccentricity is greater than 1, we know that this is a hyperbola. That's how you do it. Done. So for this one, we're going to start with that formula that we're aiming for, right? EP over 1 plus or minus E times cosine of theta. And now again, remembering that if we got cosine in the denominator of our original, right, the directrix is going to be a vertical line, okay? So just remember that. Now, let's first start by getting this into the right format. We need that 10 to be a 1. So to get it there, we're going to multiply by 1/10 on the top and the bottom, right? And that's okay, because if we multiply by 1/10 over 1/10, that's like multiplying by 1, which doesn't change the equation. All right, so 1/10 times 3 on top, we've got 3/10 over 1/10 times 10 there is 1, and then we got plus 1/10 times 10 once again is 1 cosine of theta. All right, so this tells us right off the bat that my eccentricity, or E value, is equal to 1. This also shows me that E times P, which is that numerator, is equal to 3/10. And since I know E is 1, I can get rid of this and say P is equal to 3/10. All right, so what does that mean? That means that my directrix, once again, since it's a vertical line, and this is a plus here, not a minus, we're going to go 3/10 to the right of this axis, right? So 3/10 this way. And since we have an eccentricity of 1, it means the shape is a parabola, right? A right side facing parabola going this way. So anyways, that's how you do it. Done. So for this one, once again, we remember that our formula that we're going to make these determinations on is this: EP over 1 plus E times cosine of theta, okay? And so this is how we're going to find our E value and our P value. All right, so once again, we need to get this to 1. So what am I going to do? I'm going to multiply the top and bottom by the reciprocal, which is 1/7. So 1/7 over 1/7. So 1/7 times 4 is 4 over 7. And then on the denominator, we have 1 plus 2/7 times cosine of theta. Okay, so now I can see that my eccentricity is 2/7 and E times P, or 2/7 times P, is equal to this numerator here, which is 4/7. So we're going to set that equal to each other. Multiplying by the reciprocal here of 7 over 2, boom, boom, we get P is equal to 2. So again, since we have cosine and since this is a plus, it means that if I were to draw this out, we'd have a directrix that would be 1, 2 to the right. And because the eccentricity is between 0 and 1, this is going to be an ellipse. And that's how you do it. Done. So for this one to begin, we're going to isolate the r. So we're going to divide both sides by that. So we got 11 over 3 plus 5 sine of theta. Now, we need to turn this into a 1 to get it into that nice format that we want. So we're going to multiply by 1/3 over 1/3. So that's going to give us 11/3 on top. And on the bottom, we've got 1 plus 5/3 sine of theta. Now remember, this value right here, that's our E value. So E is 5/3. And again, on top, 11/3 is equal to E times P. Now, we already know that E is 5/3, so we're going to plug and chug like so. And then to get rid of the 5/3, we're going to multiply by the reciprocal on both sides. It gets rid of that. Cancel, cancel, and we've got P is equal to 11/5. Now, since this is a plus and this is a sine, we know that the directrix, therefore, is going to be a nice horizontal line that is 11/5 above here. And since the eccentricity is 5/3 or greater than 1, this is a hyperbola. And that's how you do it. Done. So for this one, our first step is going to be to divide by this so we can isolate r. So we got r is equal to 7 over 7 plus 8 cosine theta. Then we want to turn this into a 1, so I'm going to multiply the top and the bottom by 1/7. So 1/7 over 1/7, and we're going to get 1 over 1 plus 8/7 cosine theta. Now again, my E value or my eccentricity is right there. E is 8 over 7. And to get the P value, remember that the numerator is EP. So E times P is equal to 1, knowing that E is 8 over 7. So to get P, we're going to multiply both sides by the reciprocal, which is 7/8. That's going to get rid of that. And we've got P is equal to 7/8. All right, so since we have an eccentricity of 8/7, we got cosine down here, and that's a plus right there, right? So cosine means we're going to go 8/7 to the right for the directrix. And because we have an E value that is greater than 1, this is going to be a hyperbola. And that is how you do it. Done. So for this one, we're converting the polar coordinates to rectangular coordinates, remembering that x is equal to r cosine theta and y is equal to r sine theta. So what we're going to do is we're going to start by multiplying the denominator to the right side. So then we're going to have r times 5 minus 3 sine theta is equal to 2. We're going to distribute, and then we've got 5r minus 3r sine theta is equal to 2. So now we can replace this r sine theta with y. So now we've got 5r minus 3y is equal to 2. And now I'm going to isolate the r. I'm going to add 3y to the other side, and I've got 5r is equal to 3y plus 2. Okay, now what I'm going to do is I'm going to square both sides. I'm going to square, I'm going to square. On the left-hand side, we get 25r squared. On the right-hand side, we're going to FOIL this out, and we got 9y squared. And then remember, you're FOILing, so it's 3y times 2 plus 3y times 2, which is 12y, and then plus 4. The reason why I'm doing this is because r squared is equal to x squared plus y squared. So now I can substitute that in. So we got 25 times x squared plus y squared is equal to what we had before. So now we're going to distribute, and we're going to set everything equal to 0. So we've got 25x squared. Then we're going to have 25y squared, but we're going to also subtract 9y squared from both sides. So 25 minus 9 is 16y squared. Then we're going to minus the 12y, bring it over here. We're going to minus the 4, bring it over here, set it equal to 0 because there's nothing left on the right-hand side. And there is your equation in rectangular coordinates. That's how you do it. Done. All right, for this one, we're going to start by multiplying both sides by that denominator. So I've got r times 2 plus 5 cosine theta equals 3. And then I'm going to distribute the r. And the reason why is because when I get 5r cosine theta, r cosine theta is actually equal to x. R sine theta is equal to y. So this is going to be really great. So I'm going to replace this with an x value. And now I also know that r squared is equal to x squared plus y squared, which means r, therefore, is equal to the square root of x squared plus y squared. So let's plug that in there. So I've got 2 times the square root of x squared plus y squared plus 5x is equal to 3. What I'm going to do next is I'm going to try and isolate the radical. So I'm going to add 5x to the other side, or subtract 5x, I should say. So I've got 2 rad x squared plus y squared equals 3 minus 5x. Now we're going to square both sides. Square both sides. Boom. Let's do it up here. So we've got 4 times x squared plus y squared, right? Because the squaring just kills the radical, and squaring 2 becomes 4. And then over here, we got to FOIL this. Remember, it's going to be 9. Then we're going to do 3 times negative 5x twice, right? Because we're FOILing, which gives us negative 15 plus negative 15 is negative 30x, and then plus 25x squared. And now we're going to distribute, and start to simplify. So now I've got 4x squared plus 4y squared, which is equal to all of this. And now we're going to bring everything to the left side. So we're going to write the final equation down here. So check it out. When I minus 25x squared from both sides, I'm going to get negative 21x squared, right? Because that's negative 25 plus 4 is negative 21x squared. Then I've got plus 4y squared. Then I'm going to add 30x, and I'm going to bring the 9 over by subtracting it, minus 9, and this is all going to equal 0. And last but not least, we're going to multiply everything by negative 1 to make that leading term positive. So that's going to be positive, negative, negative. This last one's going to be plus, right? And negative 1 times 0 is still 0. So that is the final answer. That's how you do it. Done. So now we're going to start by multiplying the denominator over here, and we've got r times 8 minus, and we're going to distribute it, right? 8r cosine theta, which is equal to 3. Now the reason why this is great is because r cosine theta is equal to x. So we're going to do a little substitution. And also r over here, which is by itself, we're going to convert that to square root of x squared plus y squared, because we also have that equivalency. So we've got 8 square root of x squared plus y squared minus 8, and then that becomes x is equal to 3. Okay, now I'm going to isolate the radical so I can square it and get rid of it. So we're going to add 8x to both sides. So we got 8 rad x squared plus y squared equals 3 plus 8x. Then we're going to square both sides like so. And we end up with 64 x squared plus y squared is equal to, and then we're going to FOIL this out, right? So again, that's going to be 3 plus 8x times 3 plus 8x, which gives us 9 plus 24x plus 24x, which is 48x, plus 8x times 8x, which is 64x squared. All right, this is going to be pretty cool because when I distribute this and this, the 64x squareds are going to cancel out, right? So now we're just left with 64y squared. Now we'll bring everything to the left side. Minus 48x, right? Bringing that over, and then minusing 9 as well, setting that equal to 0 because we moved everything over. And that's our final equation. Done. Now, just FYI, in the back of the book, they actually move the 48x and the 9 over. So you could also have it like this as well. 64y squared equals 48x plus 9. So that's how it matches up in the back. But again, both of these are equivalent, and that's it. So for this one, we're going to start by multiplying both sides by the denominator here, and that's going to kill it over here. And over here we have 5r minus, again, we're distributing that r to both of those terms, 11r sine theta, which is equal to 5. Again, this is awesome because r sine theta is equivalent to y. And also we can substitute in square root of x squared plus y squared for r, because that is also equal to r. So now we have 5 square root of x squared plus y squared minus 11. Again, that gets replaced with y is equal to 5. Okay, great. Now what we're going to do is I'm going to isolate the radical just to make it easier. So we're going to say 5x squared plus y squared is equal to, and we're going to add 11y to the other side, 5 plus 11y. Now what we're going to do is we're going to square both sides. That's going to become 25, and then squaring destroys the radical. So we're just going to have x squared plus y squared. And as we distribute the 25, we should have 25x squared plus 25 y squared, right, is equal to, and remember, we're going to FOIL this out when we're squaring a binomial. We get 25 plus 55y twice, which is 110y, and then plus 11y squared, which is 121y squared. Okay, now we want everything on one side, so we're going to minus all of these terms over here and bring them to the left. So we're going to still have that nice positive 25x squared. 25 minus 121 is negative 96y squared, minus 110y minus 25 is all equal to 0. That is how you do it. Done. And by the way, in the back of the book, they switched the order of these two, and then they made the first term positive. So obviously you could do that as well, right? You're just bringing the negative 96 to the front and multiplying everything by 1, which would flip all of it, right? Positive 96y squared, negative 25x squared, positive 110y, positive 25 is equal to 0. Of course, staying consistent with the rest of the answers, I would keep it like this, but that's why it's presented the way it is in the back of the book. So for this one, we're going to start by distributing that r value. So we've got 2r minus r cosine theta is equal to 1. So the reason why this is great is because r cosine theta is actually equivalent to x. And r, by the way, is equivalent to square root of x squared plus y squared. So what we can do now is we can substitute those in to get it back to rectangular format. 2 times x squared plus y squared minus x equals 1. Now to just get it in our nice format, we're going to add x to the other side. So we got 2 square root x squared plus y squared equals x plus 1. And then we're going to square both sides to get rid of that radical. So over here we got 2 squared, which is 4, and then we've got x squared plus y squared. And then over here, as we FOIL this out, we got x squared, x times 1 plus x times 1, which is 2x. Remember, we're FOILing that binomial, right? And then we've got plus 1 at the end. Now we're going to distribute, and we're going to simultaneously simplify, right? So then I'll have 4x squared. If I bring the x squared over here by minusing it, I'm going to have 3x squared. Then I'll have plus 4y squared. I'm going to minus 2x from both sides, minus 1 from both sides, and that's going to then be equal to 0. And that is how you do it. Done. So what we're going to do is we're going to start by multiplying this denominator over here, and we've got negative 2r plus 3r secant theta is equal to 6 secant theta. Okay, then what I'm going to do is I'm going to divide everything by secant theta, but that's the same thing as multiplying everything by cosine theta because secant and cosine are inverses. So watch what happens. Distribute. Then I get negative 2r cosine theta plus cosine times secant, they just cancel out because they're inverses, plus 3r is equal to cosine times secant, again, cancels out, and that's just 6. All right, this is beautiful now, because now r cosine theta, that's just x, and then r is also equal to the square root of x squared plus y squared. So now we got plus 3 square root x squared plus y squared, and this equals 6. Now I'm going to isolate the radical, so I'm going to add 2x to the other side. So we got 3x squared plus y squared equals 6 plus 2x. Now we're going to square both sides, right? We're going to square both sides. And then over here, that makes 3 squared is 9. Square the radical, that kills the radical. So we got x squared plus y squared. Now it's in parentheses still, but let's go ahead and just distribute that 9 in this step, right? The 9's going to jump to each of those terms, and that's equal to, let's FOIL this out, 36, 6 times 6, plus 6 times 2x plus 6 times 2x, because again, we're FOILing the binomial, so that is 24x, and then plus 2x squared, which is 4x squared. Okay, now we're going to bring everything to the left side to finish this off. So minus 4x squared, 9 minus 4 is 5x squared, plus 9y squared. Then we're going to minus that 24x and minus that 36. So then the only thing that's left on the right-hand side is 0. And that is how you do it. Boom, done. So for this one, the way we're going to graph it is we're going to start by recognizing that when we graph it on the rectangular plane, one of the foci is going to be right here on the origin. Then to get 4 other good points, what I'm going to do is I'm going to plug and chug with theta and corresponding r values. So the ones I'm going to plug in that are the easiest are going to be 0, pi halves, pi, and 3 pi halves. Remembering that 0 is going to be along here, pi halves is going to be up here, pi is going to be out here, and 3 pi halves is going to be down there on that axis. So let's go ahead and plug these in. Now, if I plug in 0 for cosine, cosine of 0 is 1, 2 plus 1 is 3, so we've got 5/3. Then I plug in pi halves, cosine of pi halves is 0, 5 over 2 is therefore the result. Plug in pi, that's -1, cosine of pi is -1, so 2 plus -1 is 1, 5 over 1 is 5. Last but not least, we got 3 pi halves. Cosine of 3 pi halves is also 0, so then we're going to once again have 5 over 2 for this value. Okay, let's plot these out. So we got 0 and we've got 5/3, so that's 1 2/3, so maybe like right here, and that's one of the vertices, and there's the equivalent point in the xy coordinate plane. Then we got pi halves at 5 over 2, which is 2.5. Let's put it up here, and again, that's going to be 0, 5 halves. All right. Then over here, we've got pi 5, which is going to be right here, and that's going to be -5/0. That's the other vertex. And then we've got 3 pi halves and 5 over 2, which is going to be down here like this. So if I were to graph the ellipse, it would look something like this. And again, for the foci, I'm going to put this one right here, which is at the origin. And to figure out where the other one is, I can see that this is 5/3 from that vertex. So this one's going to be 5/3 in. So we can say it's -5 plus 5/3. And to get common denominators, multiply this by 3 over 3. And that's -15 plus 5 is -10 over 3, which is -3 1/3. So it's about, here's 3, here's 1/3. So we got the other foci at -10/3, 0 as a rectangular coordinate. That's how you do it. Done. So for this one, once again, we're going to make a little chart here with theta and r values. And I'm going to plug in 3 standard values for theta that are going to make it really easy. We're going to plug in 0, pi halves, pi, and 3 pi halves, right? Those key points where 0, the r value is going to be on here, pi halves here, pi here, and 3 pi halves here. So let's check this out now. So we're going to plug in 0. Sine of 0 is 0. 5 minus 0 is 5. 10 over 5 is 2. Then we got pi halves. Sine of pi halves is 1. So that's 4 times 1 is 4. 5 minus 4 is 1. 10 over 1 is 10. Okay, then we've got pi. That is, again, 0. So it's 10 over 5, which is 2. And then we're going to plug in 3 pi halves, which is, once again, -1 this time. So we've got 10 over 5 minus 4 times -1. -4 times -1 is +4. And then we got 5 plus 4 and 10 over that. So that's 10 over 9. All right, let's plot these out. And again, remember, one of our foci is going to be at the origin here. Then we got 0, 2, like this, pi halves. That's right up here on this axis at 10. Then we got pi at 2, but that means going this way, so that's out here. And then we got 3 pi halves at 10/9. That's a little bit more than 1. That's 1 1/9 right there. Now, since this has sine on the bottom, we're talking about an ellipse that is going this way, right? And by the way, we know that this is an ellipse because when I multiply everything by 1/5 over 1/5, right? That's going to turn that to 1, and my e value right here is going to be -4/5, or just 4/5, really, we can say, for this intents and purposes. And between 0 and 1, we know we have an ellipse. So here's our graph, and again, we have a vertice right here at 0, -10/9, right, in rectangular format. Up here, it's going to be 0, 10. And then for the foci, once again, we know that one is going to be at the origin, and that's always going to be the case. And then the other one, right, we can look at how far in it is from the other vertex, which is -10/9 or 10/9 above it, right? So we could take this one and we go 10/9 below, which would be approximately right here. And then to calculate that exact value, it's 10 over 1 minus 10/9 multiplied by 9 over 9. 90 minus 10 is 80 over 9. And so this one right here is 0, 80 over 9. So there's the foci, there's the vertices. That's how you do it. Done. So for this one, we're going to start out by multiplying top and bottom by 1/4 to turn that into the nice standard form, right? So 1/4 times 8 is 2 over 1 minus 5 over 4 cosine theta. Now, since this is my e value and e is greater than 1, we know that this is a hyperbola. Okay, and we also know that because we have cosine down here, we know that we're going left, right, right? It's going to go like this as opposed to up, down. Now let's make our table and get a couple of points here. Again, we're going to go 0, pi halves, pi, and 3 pi halves. Let's plug and chug. 0 in, cosine of 0 is 1, 4 minus 5 is -1, 8 over -1 is -8. Then we got pi halves, cosine of pi halves is 0, 8 over 4 therefore is 2, boom, done. When we plug in pi, that's cosine of pi is -1, 4 minus -5, which is 4 plus 5, which is 9, and this gives us 8 over 9. And last but not least, 3 pi halves. Cosine of 3 pi halves is actually 0, so again, it's 8 over 4, which is 2. Now we're going to plot these out where we know that 0 is going to go here, pi halves is going to go somewhere here, pi is going to go like this, and 3 pi halves that way with these different values. So 0, -8, well, negative means we go in this direction, and we're right there. Then we got pi halves 2, that's going straight up, we got the 2. Then we got pi 8/9, so pi is going this way, and 8/9 would be like right there. And then we've got 3 pi halves going down, and there's our 2. Now we can see that we've got one vertex right here, and that is on the rectangular coordinate, that's going to be -8/9 on the x, 0 on the y. And this looks like our other vertex, which is at -8, 0 in rectangular coordinates. Now again, as per usual, we have that nice foci that we know we can count on at the origin, 0, 0. And so where's our other one? Well, we can see the distance right here is 8/9 away, right? So it's going to be the same kind of thing. It's going to be 8/9 in this way, right? Or the way we can think about it is -8 plus -8/9. So to get common denominators, multiply by 9, that's -72 plus 8, -8, I should say, is -80 over 9. So that's like right about here. And there's our other foci, -80 over 9, 0. And then we're just going to kind of roughly draw in the hyperbola. So it's going to go up like this, roughly down, obviously very rough estimate. And then we're going to go up like this. And as I mentioned, it's going left and right. So anyways, that's how you do it. Done. So for this one, we've already got it in our nice standard form, and we can see that our e value is right in front of the sign. It's an invisible 1, so e is 1. And again, this is a sign over here. That means we either have a parabola going up or going down. Now we can find the p-value to get us the directrix. So we know that e times p is equal to this numerator, which is 2. Since e is 1, p is equal to 2. And since this is a minus, what this means is that the directrix is 2 below the origin, meaning it's at y equals -2, and therefore our parabola will be opening up. So since we know the focus is at the origin, our vertex is exactly in between the focus and the directrix, so it's right here at 0, -1, and the focus, as I mentioned, is at 0, 0. Now we're just going to plot a couple of points, and then we're going to graph the remainder of this parabola. So we're going to start with 0, pi halves, pi, and 3 pi halves. Let's get those corresponding r values. So plug in 0, sine of 0 is 0, 2 over 1, therefore is 2. Pi halves, sine of pi halves is 1, that's undefined. Then we've got regular pi, sine of pi is 0 again, so that's 2. And then we got 3 pi halves, that's going to give us -1, so 1 minus -1 is 2, 2 over 2 is 1. And that actually is just going to give us our vertex already, right? Because we're going on this part down by 1. This is an A, right? We said that that was undefined, so let's plot these out. So on 0, we're going this way, and it says 2 out, so we're going to go right there. Pi, we're going this way, and we're going 2 out that way. That's -2, 0. Those are our 3 points. Let's connect them. And there you go. That's how you do it. Done. So for this one first, let's get it into our nice format. We're going to divide the right-hand side by 1 plus cosine theta. So we got 1 plus cosine theta. Now it's in our nice standard form. And I know that my e value is 1, right? It's right in front of here. And since I know that e times p is equal to the numerator of 5, and since e is 1, p is equal to 5. And with an e value, an eccentricity of 1, we know this is a parabola. Since we have cosine on the bottom, this parabola is either going this way or this way. Once again, with that focus being at the origin, and this being a 5 and that being a plus, we know that the directrix is 5 units to the right. So there's my directrix at x equals 5. And of course, my vertex is going to be right in the middle of the directrix and the focus, so right here at 2.5 comma 0. Now let's get a couple of points to finish the graph. So again, we got 0, pi halves, pi, and 3 pi halves. Let's get those corresponding r values. So I plug in 0, cosine of 0 is 1, 5 over 1 plus 1 is 5 over 2. Plug in pi halves, which is going straight up. Cosine of pi halves is 0, 5 over 1 therefore is 5. Cosine of pi is -1. That's going to be undefined, so we'll just say not available. And then 3 pi halves. Cosine of 3 pi halves, once again, is 0. 5 over 1 is 5. So for 0, 5 halves, that's right here. We already got that. That's the vertex. For pi halves, we've got 5 up this way. So that's 0, comma 5. Over here, we got pi not available. And then 3 pi halves, we've got 5 down coming this way. And so now let's connect the dots like so. Boom, like so. Boom, and that's how you do it. Done. So for this one, let's start by dividing by this. So we got r is equal to 6 over 3 minus 2 sine theta. And let's get into standard form, multiply the top and bottom by 1/3 to turn that into a 1. So we got r is equal to 2 over 1 minus 2/3 sine of theta. And I have an e value right here as of 2/3. And since it's less than 1, we know that this is going to be an ellipse. And since we've got a sine value here, we know it's going to go longer this way. And knowing we've got one of our foci at the origin, we can now begin with our little t-chart. So we got theta, r, we've got 0, pi halves, pi, and 3 pi halves. Let's get those corresponding r values. So first, let's plug it into the original. I think it'll be easier without the fraction. So we plug in 0. Sine of 0 is 0. 6 over 3, therefore, is 2. Plug in pi halves. Sine of pi halves is 1. So 2 times 1 is 2. 3 minus 2 is 1. 6 over 1 is 6. Now, you can do this in a calculator as well. Sine of pi is, again, 0, so that's 6 over 3, which is 2. And then 3 pi halves. Sine of 3 pi halves is -1, so it's going to be 3 minus -2, which is 6/5. So let's plot these out. We've got 0 coming out this way, and we've got our 2 right here. And then we've got pi halves, and that's going straight up at 6. We've got pi going this way, going out to 2. And then we've got 3 pi halves and 6/5 right here. So there's our ellipse. Here's one of the vertices at 0, -6/5. Our other vertice or vertex is right here at 0, comma 6. And now we need our last foci. So I see here this foci is 6/5 above. So this one's going to be 6/5 below, which would be 24/5. And that's how you do it. Done. So for this one, we know that if E is 1/5, that's the eccentricity. If the directrix is x equals 4, P is equal to 4. So now we can start to make this equation. We've got R is equal to E times P, which is 1/5 times 4, which is 4/5 on the top. And then on the bottom, we've got 1 plus my E value of 1/5. Now, since it's x is equal to 4, right, a vertical directrix, we know that we're going to have cosine of theta down here. Now, to get it into nice format, we're going to get rid of the fractions by multiplying by 5 over 5 like so. And then we've got r is equal to 4 over 5 plus 5 times 1/5 is 1 cosine theta. That's how you do it. Done. So for this one, we got an E value of 2 and a P value of 2, right? So we got P is 2, E is 2. And then we know that on the numerator of this, right, it's going to be E times P, which is 2 times 2, which is 4, over 1 plus, and then we have the E value 2. And now the question is it sine or cosine? Well, since I have a directrix of y equals 2, meaning a horizontal line, it's going to be sine theta right here. And that's how you do it. Done. So for this one, we got a directrix of x equals 1, and that means our p value is going to equal 1. And now we can make our equation. We've got r is equal to, again, we've got e times p, which is 1 times 1, or 1, over 1 plus, and again, since we have x equals 1 as the directrix of vertical line, we know that we should have cosine of theta here. And that e value in front of the cosine, but that's 1. So we're going to leave it as is. So this is our final answer. Done. So for this one, we've got a directrix at x equals -1/4, which means our p-value is 1/4. But again, because that's a minus, we're going to have a minus on the denominator as well. So now we're going to have r is equal to e times p, 7/2 times 1/4, which is 7/8, over, and then we've got 1 minus, again, if it's a directrix of x equals, we know we have a cosine theta with that e value in front of 7 over 2. Now to turn everything away from fractions by basically making them all into integers, we're going to multiply everything by the least common multiple of 2 and 8 right there, which is going to be 8. So we'll multiply by 8 over 8, and then on top we get 7 over 8 times 1 is 8, minus 8 times 7 halves. 8 divided by 2 is 4, times 7 is 28 cosine theta. That's how you do it. Done. For this one, we got a p-value of 4. Again, it's y equals. That means we're going to have sine in the denominator. So we got r is equal to e times p. 3 halves times 4 is 6 over 1 plus, like I said, sine of theta. But then we need that e in front, which is 3 over 2. Now to turn this back into a nice integer, we're going to multiply everything by 2 over 2, right? So we got r is equal to 12 over 2 times 1 is 2 plus 2 times 3 halves is 3 sine of theta. That's how you do it. Done. So for this one, that directrix means we have a p-value of 5. Since it's x equals for the directrix, we know we have cosine on the denominator. And since it's minus 5, we're going to have a minus in between. So we got r is equal to p times e, which is 15 over 4 on the top, over 1, again, minus, and as I mentioned, it's going to be cosine of theta with that e value of 3/4 in front. Now to get rid of those fractions, we're going to multiply by 4 over 4, and we've got r is equal to 15 over 4 minus 3/4 of 4 is 3 cosine theta. That's how you do it. Done. For this one, we got a p-value of 3, and again, because it's x equals, right, we're going to have cosine on the denominator, and now we have r is equal to e times p, 1/3 times 3, which is 1 over 1. Because that's negative, it's going to be minus, and then my e value of 1/3 cosine of theta. To get rid of that fraction, we're going to multiply by 3 over 3, and r is finally equal to 3 over 3 minus cosine theta. That's how you do it. Done. So for this, we're going to express it in polar form. And how I'm going to do that is I'm going to first rearrange this as x squared plus y squared. Okay, I'm going to put those two terms together, plus xy is equal to 4. The reason why is because x squared plus y squared is actually equal to r squared. So that's going to begin my substitution, right? R squared plus xy is equal to 4. Now, x is also equal to r cosine theta, and y is equal to r sine theta. So as we plug these in for x and y, we're going to get r squared plus r cosine theta times r sine theta is r squared cosine theta sine theta is equal to 4. Now I'm going to factor out r squared from both sides. R squared times 1 plus cosine theta sine theta is equal to 4. Now I'm going to divide by this quantity here. So I've got r squared is equal to 4 over 1 plus cosine theta sine theta. Last but not least, I want to get rid of that square, so I'm going to square root both sides. Squaring a square just destroys it, and so I've now got r is equal to the square root of 4 over 1 plus cosine theta sine theta, plus or minus, of course, but I can take the square root of 4 on top. So finally, we've got r is equal to 2 over plus or minus 1 plus cosine theta sine theta, and that is how you do it. Done. For this one, I'm going to have to just do a straight up substitution of x equals r cosine theta and y is equal to r sine of theta into each of these x and y terms. So we're going to start with 16. Instead of x, we're going to have r squared cosine squared theta plus, and then 24, and then we're going to have r cosine times r sine. So we've got r squared cosine theta sine theta, and then we got plus 9, and then instead of y squared, we're going to have r squared sine squared theta is equal to 4. Now it looks like I got r squared, and r squared. Let's factor that out of all of these. So I got r squared times 16 cosine squared theta plus cosine plus 24 cosine theta sine theta plus 9 sine squared theta is equal to 4. Now, what you might not realize is we got a little something interesting here, which is a perfect square trinomial. Okay, so we can actually factor this. And it's going to be the square root of 16 and the square root of 9 for the first and last term. So it's going to be 4 cosine theta plus 3 sine theta squared. It's perfect square, right? If I FOILed this out, it would be 16 cosine squared theta, right? Then that would multiply that twice, and we'd add those together. That would give you the 24. And then again, at the end, it would be this term squared, which is this, right? So that's pretty nice that it works out this way, and this equals to 4. Now we're going to divide both sides by that denominator. So I got r squared is equal to 4 over 4 cosine theta plus 3 sine theta. And all of this is squared. Last but not least, let's take the square root of both sides. Boom, boom. And we get r is equal to, and because we did the square root, it's got to be plus or minus. Square root of 4 on top is 2. Square root of this thing squared on the bottom is just that thing, right? 4 cosine theta plus 3 sine theta. And that's how you do it. Done. I hope you guys enjoyed this video, and if you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.